So let's continue with the inverse Laplace transform. So earlier I have shown you the function and their Laplace transform. So now I'm going to present to you inverse Laplace transforms. The given here is f of s, and the final answer is f of t. Again, just to recall, if the Laplace transform of a function f of t is f of s, let's say Laplace of f of t in this operator is equal to f of s. The value of f of t is called an inverse Laplace transform of f of s. Again, f of t is the inverse Laplace transform of f of s. And we can actually utilize this symbol to represent the inverse transform operation. Tapos we use brackets. Yeah, so this symbol here is called the inverse Laplace transformation operator. Now to find the inverse transforms like this one. So remember the following standard forms. We know that 1 over s is the Laplace of 1. So the inverse of 1 over s is 1. Now, we know that 1 over s minus a is the Laplace transform of the function e raised to at. So, the inverse transform of 1 over s minus a is e raised to at. So, just stick with the standard form. If it's not satisfied with the given standard form, so you just have to introduce something or to multiply something in the given, just like this one. Here, kaya siya may 1 over b dito. So, because the given here is 1 over s squared plus b squared. And we know that this transform is similar to the transform of sine of bt, provided that the numerator should be b. Okay, similar to this one. So, b, the numerator. So, what you will do is you introduce b over b. So, you put b here and then neutralize mo sa labas. So, yeah, neutralize it. So, b over b is still 1. Kaya you have here 1 over b sine of bt to satisfy the given formula. Now let's solve some examples. Find the inverse transform of s squared minus 3s plus 4 over s cubed. We are to find the inverse. So ganito yung ating symbol. Find the inverse of s squared minus 3s plus 4 over s cubed. So in the inverse Laplace operation, we still follow the same property, linearity property. So we can take the inverse of each term. So firstly, we divide each term of the numerator by s cubed. So here we have s squared over s cubed minus 3s over s cubed plus 4 over s cubed. So as you can see, we can cancel s squared here. So we have 1 over s. You can cancel s. That will be 3 over s squared. And for the last term, we just have to copy 4 over s cubed. Now going back, we can take the inverse of each term. So it's the inverse of 1 over s. And here you have minus 3. You put the constant before the operator. So inverse of 1 over s squared. And lastly, so plus 4 inverse of 1 over s cubed. Okay, for the first term, so this is the Laplace of the constant. So you just have to write 1. Laplace of 1, inverse Laplace of 1 over s is 1. For the second term, okay, take a look at this one. So you have s squared. Remember, s raised to n plus 1. The n here, the n of t is 1. So it means that the numerator should be 1 factorial. And since 1 factorial is equal to 1, so no worries, we still satisfy, of course, the given formula for the transform of t. So the answer here is 3 or minus 3t. And for the last term, we have 1 over s cubed. The inverse transform of this is similar to t raised to n. In this case, n here is what? N plus 1. So 3. It means that n is 2. For t squared, remember that the Laplace of t squared is, it should be what? 2 factorial over s raised to 3. So we have 1 over s cubed. We just need to put 2 factorial here. But if you put 2 factorial here, you have to make sure that you neutralize. Okay, so you put 2 factorial and then you neutralize 2 factorial outside. So it's still the same, that we have 1 over s cubed times 4. Okay, so the answer there is plus 4 divided by 2 is 2t squared. So this is the final answer. This is the inverse transform of this given f of s. That's the final answer. Or you can arrange actually the given f of t from the highest degree of t. Next one, find the inverse transform of 12 over s minus 5 minus 2s over s squared plus 49. So take a look at the given f of s. So first term, you can see that it's applicable that this is a transform of exponential function. Remember the first shifting property? And for the second term, you have s in the numerator and denominator, you have s squared plus 49. So it means that possibility of f of t being equal to cosine. Now, because of its form. So factoring out or putting 12 before the operator. So 12 inverse Laplace of 1 over s minus 5. So it's clear now that we have e raised to at, and our a here is positive 5. And for the second term, we just have to put the constant before the operator. So minus 2 inverse transform of s over s squared plus 49. And take note that it should be perfect square, or the square of b. So get the square root of this, we have 7. And 7 squared is equal to 49. So we can write the final answer or to be, for the first term, 12 times e raised to at. A is equal to 5. So that's why we have e raised to 5t minus 2 cosine of b times t. Our b here is 7. That's why we have cosine 7t. Or we can factor out to, yan, we have this resulting inverse transform. So this one now is in f of t format. So 2 times 6 e raised to 5t minus cosine of 7t. Or simply, you can actually enclose this as your final answer also. This one is in factored form. Now, for example number 3, find the inverse transform of 3 over s squared plus 5. Okay, so what do you think? So again, we are not going to utilize partial fractions yet. Notice or observe the given f of s. The numerator is constant and we have s squared plus 5. So the possibility of sine as the f of t. So what's the Laplace? Recall natin. Laplace of sine of b times t. So remember, the Laplace of this one is b over s squared plus b squared. So as you notice, and our b squared here is equal to what? 5. So if we take the square root of both sides, we have b equal to square root of 5. Now, what we do is put the constant before. So we have inverse of, so what have we here? We have s squared. Let's follow this formula. What is our b? Square root of 5. So square root of 5 squared is still 5. We did not violate anything or any rule here. So if we put square root of 5 in the numerator, okay, we did something wrong. But we did it right if we neutralize outside. Okay, we put square root of 5. It's as if that we introduced 1, or we multiply this entire expression by 1. Kasi square root of 5 divided by square root of 5 is equal to 1. The final answer here will be, so just copy 3 over square root of 5. This now is actually the Laplace transform of sine of b times t, sine of square root of 5t. Ayan.
You can rationalize this one.
Yeah, multiplying square root of 5 over square root of 5, this becomes 3 square root of 5 over 5 sine of square root of 5 times t. This is now your final answer.
Let's try this final problem. Find the inverse Laplace of
3s minus 4 all over s squared plus 6s plus 13. So quadratic, right? And the numerator, so you have s. So supposedly, the possibility of having first shifting property because of this one. Yeah, remember this one, the first two terms. We make it a perfect square. So
we do completing the squares.
this result, 3s minus 4 over s plus 3 squared. And then that will be 13 minus 9s plus 4. Eh, perfect square na rin to. Ito for perfect square. However, yung numerator, sir, paano yan? S minus 4. Dapat s plus 3 yung numerator eh. Now, we have, sa first term natin, ayan na, sulat na natin. Constant na yung 3, di ba? So, 3 inverse Laplace of s plus 3 over s plus 3 squared plus 2 squared. That's the first term. So, ano to? First shifting property ng cosine, right? So, this one will be 3 times e raised to at. What is our a here? Negative 3. E raised to minus 3t cosine of, what is our b? 2. So, 2t. That's the first term. For the second term naman, we have 13. Constant yung ating numerator. So, possible of having sine as our f of t. So, factor out mo lang yung 13. Tapos, inverse transform ni the same denominator as you just put denominator. The same denominator. So, what should be our numerator, guys? So, it should be 2 yung numerator, di ba? Para magamit yung sign. So, naglagay ako ng 2. Eh, babawiin ko sa labas. Neutralize mo siya para wala kang ma-violate na rule. So, the second term will be minus 13 over 2 e raised to, first shifting pa rin siya, minus 3t sine of 2t. That's it. Wala mo ng partial fraction.